Hello and welcome to our first lecture of Algebra 2. This lecture is going to cover sections 1.1 and 1.2, and this will cover facts about the real number system. This lesson is going to be very heavily focused on vocabulary and just kind of some basic ideas of numbers. Let's start with this concept of a real number. So in your mathematical career so far, you've learned a lot of different numbers, obviously. Every number that you guys are aware of, even like the really weird ones, if you think of like pi or something, every number that you guys are aware of would be classified as a real number. That is to say that there is such a thing as a not real number. Okay, we are going to be learning about imaginary numbers in this course. It's one of the main things that we learn about in Algebra 2. However, up until this point, you are only aware of the real numbers, and within the real numbers, there's going to be different terms that we're going to use to classify them further, and that's what we're going to look at right now. So the real numbers are all numbers that are either rational or irrational. Okay. Kind of a worthless definition if you don't know what rational and irrational means, so let's go ahead and look at those. Your irrational numbers are numbers that can never be written as a fraction. Okay, that's the best definition of it. They can never be written as a fraction. That's the one I like the most. You could also try to think, we can transfer numbers between fractions or decimals. So if you were to think of them as a decimal, irrational numbers are numbers that their decimals don't terminate, don't stop, or they never repeat. So if your decimal goes on forever, never terminates, never repeats, okay, that would be an irrational number. Also, irrational numbers could never be written as a fraction. The rational numbers would be things that could be written as a fraction or as a decimal. The decimal will terminate or will repeat. So if we're to think about different numbers that we are aware of, your irrational number, the main one that you guys, I think, generally come up with would be pi. Okay, pi is a number, 3.141592. You guys know it goes on forever. Okay? What's unique about it is it goes on forever, but it also never terminates, right? Obviously, or it never repeats. Okay? It goes on forever, and the numbers don't just fall into a pattern. There are also other irrational numbers that you guys should be aware of, and a good example of this would be the square root of 2. Okay? And the square root of 3 is also irrational, and we could keep going. This is an infinite set of irrational numbers. But those are the two main ones that we'll kind of use to talk about at this point. Now, your rational numbers can look like a lot of different things. We could think of them as a fraction, so 1/2. 1/2 is rational. Hey, it can be written as a fraction because it is a fraction. Okay. We also know that 0.5 is the same as a half. This is what it would look like as a decimal. That decimal terminates, right? It doesn't keep going on forever. We could also look at something like 1/3. Okay, we know 1/3 is rational because it's written as a fraction. As a decimal, 1/3 is written as 0.3 repeating, right? It goes on forever. So that's where this, rational numbers can either terminate like 0.5 or repeat like 0.3 repeating. Also classified as rational numbers would be something like 5. Okay? The number 5 is rational because it could be written as a fraction. I could write 5 as 5/1 if I wanted to. Therefore, it could be written as a fraction, and it is rational. Up next, we have the integers. The integers are all of the counting numbers. I've kind of listed an infinite set. Okay, the infinity is designated by the ... there. So numbers that we generally count by 0, 1, 2, 3, going on forever. Also going forever in the negative direction. -1, -2, -3 would be all examples of the integers. Okay, these are the things that you generally would count by. I want to make a point to say that all integers are also rational numbers. Okay, but not all rational numbers are integers. For example, right, 5 is an integer. We'd eventually have that in this set. Okay, so 5 is an integer. It's also rational. 1/2 is a rational number that is not an integer. Our last definition we're going to look at right now would be the whole number system. Whole numbers are the not negative integers. Okay, so if we're thinking of this list of integers right here, the ones that are not negative, so going from infinity, crossing them out until -1, we have to cross out the negative ones, right? So starting at 0, 1, 2, 3, those would be your whole numbers. This is kind of a nice image when we're trying to understand what it means, how the numbers fit together. Keep in mind that there would be like another idea. These are all just the real numbers. There is another set of numbers that would be somewhere out here, known as the imaginary numbers. But at this point, we only know about the real numbers. We can classify real numbers as either rational or irrational. Irrational numbers, we don't really classify them further. We have the square root of 2. We could have pi, right? We're going to learn about other irrational numbers this year. When we get over to the rational side, 3/4 is rational. It's 0.75. So is -1/3, okay? Or -0.33 repeating. The integers would be another set of numbers that are real, okay? -1 does kind of fit in this rational number boxes, right? As well, right? -1 is rational, -4 is rational. A smaller grouping of those would be the whole numbers, like 0, 3. So I think this is kind of a useful graphic for understanding kind of how we classify these numbers, and we're going to refer to these throughout the year. So this is going to be something you guys are going to want in your notes to refer to. And I do want to make a point to say that on all quizzes, you are able to use your notes. So when I come up with questions, let's say like classify the number with its most descriptive term. That's what it'll look like this. What is the most descriptive term for a given number? So you're going to have to look at 3.4 and pick what its most descriptive term is. Hopefully you guys are, kind of thinking through this with me. 3.4, its most descriptive term would be rational. Okay. This is supposed to be a fun game, but it apparently isn't working. We'll try one more time. So 3.4 is rational. The square root of 8, its most descriptive term would be irrational. We don't really classify things further than irrational, but rational numbers, we do try to classify them further, right? The number 0 is a rational number, but more specifically, it's an integer, and even more specifically than that, it's a whole number. Remember, whole numbers start at 0, 0, 1, 2, 3, and so on and so forth. 10/2. 10/2 is also rational because it can be written as a fraction, and it is currently. 10/2 simplifies to 5, and 5 is an integer. But more specifically, 5 is a whole number. And then -7 we know is an integer. It looks like I have one more down here. The negative square root of 9. We know the square root of 9 is 3, so -3 is the number that this is equal to, and -3 is an integer. Almost right there. The next thing I want to talk about is something that I feel like students coming into this class don't really have a great grasp of. And so I just want to talk about what the difference is between -2 to the third power and -2 with parentheses around it to the third power, because they do mean different things, whether it's written like this or this, but sometimes they have the same answer. And so students often get confused with what this means. Throughout your math career, you guys have been learning about the order of operations, and that is going to come into play here. PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. So -2 to the third power. What is that question asking when it's written like this? Well, we know that exponents come very early in the order of operations. Exponents come before anything to do with the subtraction symbol. And so what this question is actually asking is you're going to take the number 2 to the third power, and it's going to have a negative sign in front of it. So it would be 2 to the third power is 2 times 2 times 2, and then this negative sign is still going to be out front. So when you actually do this math, -2 times 2 is -4, and -4 times 2 would be -8. And you guys should type that into your calculator, and you should be able to verify that -2 to the third power is -8. Now, when we get over to this question here, -2 with parentheses around it to the third power, that is asking something different. It's asking you to take the number -2 to the third power. So what that would equal would be -2 times -2 times -2. And this, as you can see, is a different question. Okay, -2 times 2 times 2, or -2 times -2 times -2. -2 times -2 is going to give us +4, and +4 times -2 is still going to give us that answer of -8. So we did end up with the same answer, -8 and -8. And so some of you guys might be thinking, well, it doesn't really matter whether I have the parentheses there or not, but that's not the takeaway I want you to get here, because sometimes it does. So when we come to this example here, -3 to the second power with no parentheses, right? Once again, that to the second power is saying, hey, take the number 3 and square it. But then we have this negative sign here. -3 times 3 is the number -9. However, -3 to the second power would be saying, hey, take the number -3 and multiply it by itself. And -3 times -3 is +9, a different answer than this -9. So you guys have to be very deliberate in paying attention to if there's parentheses or if there's not, especially when it comes to exponents. You're going to notice that if you typed in -2 to the third power as it is in your calculator right now, you'd get -8. You're always going to get the right answer if you type it in correctly. So your calculators are going to be right. It's just a matter of if you're going to be typing them in right. And most students are going to lose points throughout the year for something like this. And we're going to keep coming back to this idea of, okay, you lost your negative, right? A lot of students have questions about negatives, or they get their problems with negatives in them wrong often. And a lot of it could be fixed. You're going to be using your calculators a lot here. If you're able to just type that in correctly, you should be fine. This is kind of utilizing that, so kind of putting it to practice. What I want you to do is I want you to evaluate when x is the number 2 and y is the number -3. So what that would be is you're substituting 2 in anywhere where there's an x, and you're substituting -3 anywhere where there is a y. Now, this is something that I don't know if it was emphasized to you a lot, once again, in your prior algebra courses, but I want to emphasize it starting now. Anytime you substitute a number in, if you're going to be substituting 2 in for x and -3 in for that y, when you substitute a number in, put that number in parentheses when you rewrite it. That should be your first step. Okay? If it isn't your first step, and I can point to questions, specific questions throughout this year that people are not going to do that, and they're going to get it wrong because, like, I know the answer. I know what two negatives do, or so on and so forth. However, this is a very common mistake, and I don't want you to make it. So when you substitute something in, put it in parentheses. So this 2 is going to go in for x. So it's going to say 2 times 2 to the second power. Notice where there was an x, I put in a 2, and I put that in parentheses. Carrying on, we have this negative, and then I'm substituting a -3 in for y. And then -3 in parentheses because I'm substituting it in. And now I'm going to start paying attention to simplifying this. And our calculators, when we do this, are going to be right. But it's when we don't do that and we just start trying to mess with the negatives right away that we're going to get the wrong answer. We know, so going back to our order of operations, there's nothing in the exponents we can simplify. So then we'll go to the exponents. 2 squared is 4. So we're going to have 2 times 4 minus -3 to the third power. We can actually do that. Remember, -3 to the third power is saying -3 times -3 times -3. -3 times -3 is 9, and 9 times -3 is -27. -3 squared, once again, we have to pay attention to those parentheses, and we can lie in our calculators. We can type that in and get the right answer. When the wrong answer is when you don't put those parentheses in, and you're going to get 9. From here, once again, you can use your calculator for this stuff. And if 8 minus a -27, minusing a negative does turn into addition. So we're going to have 8 plus 27, which is 35. 35 over 9 is going to be our answer. Now, many of you, based upon prior courses, you would take 35 over 9 and you would turn that into a decimal. I'm going to discourage you from using decimals. I'm going to be encouraging you to use fractions. I will tell you it's much easier as we progress into more difficult math to be using fractions rather than decimals. And specifically, I do not want to see any mixed numbers. I do not want to see you convert this to like 3 and 8 ninths. Okay, I know you spent a lot of time in elementary math learning how to convert numbers like this into numbers like this here, converting your improper fractions to mixed numbers. However, mixed numbers are in algebra 2 ugly. We don't like them. I want improper fractions. So go ahead and give this one a try. Push pause, try it out. Make sure you're able to get to the right answer. And I will proceed here. Once again, we're substituting these numbers in for x and y, and when we substitute something in, we're going to put it in parentheses. Notice this negative sign did not get put in the parentheses. Okay? 2 is the thing I was substituting in, so 2 is the thing that's going to be in parentheses. I'm squaring the number 2. Squaring the number 2 is going to give me 4, but there's that negative sign out in front of it. In negative 3 to the 3rd power, we can type this in properly into our calculator, putting parentheses around negative 3, and get negative 27. We're going to end up with negative 1 over negative 27, which a negative divided by a negative is always positive. We're going to get the answer 127. Up next, I want to talk about a couple more terms. The term variable, coefficient, and constant. It's my belief that you know these things, but I just want to reiterate them. And if you don't know them, make sure they're in your notes. A variable is when we use a letter in place of a number, right? So when you start incorporating the letters in math, that's when you start incorporating variables. So we have the variable of x in this problem. We're going to have problems where we have multiple variables. We're going to have problems where we have one variable, but variables are going to be in most of the things that we use. A coefficient is a number in front of a variable. So we have a couple coefficients in this problem. We have the coefficient of 3 and the coefficient of 2. The coefficients on, one's the coefficient on x squared, and one of them is the coefficient on x. That's okay. If I asked you to list the coefficients here, you'd just be like, okay, 3 is a coefficient, 2 is a coefficient. A constant is when there's a number that has no variable with it. It's constantly negative 4 right here. Right? There isn't, no matter what x is, this is constant. It's the number 4. So you're going to hear me use these definitions all the time. I just want to make sure that you guys are aware of them. And then we are going to be at our properties of real numbers, and this is going to be kind of an important part of what we talk about today. Maybe the most important part. It's going to be something that I kind of use throughout the year, especially some of them more than others. So make sure that you have this in your notes. These are called the properties of real numbers. And the first one is called closure. I'm not going to talk much about closure right now. What it basically means that a number system is closed or has closure is that if you took the two numbers, A and B, and you added them together, okay? So if you took two real numbers and you added them together, you would still get a real number. You're not going to leave the real numbers by adding two real numbers. And same thing with multiplying them. If you multiplied two real numbers, you're not going to suddenly have a real number. Now, I know you guys only know what real numbers are, but this applies to integers as well, which you guys have a good grasp of, right? If you added two integers, you would still have an integer. Or if you added two whole numbers, you would still have a whole number. If you added two rational numbers, you're not going to suddenly have an irrational number. The next property that we have is called the commutative property. And the commutative property says that when you add a number with another number, I could put actual numbers here. If I took the number 2 and added it with 3, I would get the same thing as if I took 3 and added it with 2, right? 2 plus 3 is the same as 3 plus 2. I know that you guys know that that's a fact, right? You know that both of them are 5. What I need you to be able to do is to identify that that is the commutative property when you see that, okay? When you see on a quiz or a test, hey, 4 plus 7 is the same as 7 plus 4. How do we know that? You need to be able to come up with the answer of the commutative property. I think this one is an easier one to come up with, simply because we know there's a root word here that we can kind of relate to. We know what a commute is, right? The commute, my commute, is when I drive from my house to the school. Look at these fancy drawings. Okay, so I go from my house to the school, and then on the way home, I'm going to go from the school, we'll go over here, to my house. Gosh, that's ugly, but you know, house to school, school to house. You're taking the same things and you're reversing the order. That's what we call a commute. Pretend that made sense. Thank you. Okay. Up next is the associative property. The associative property, once again, I know that you're going to know this is a true fact. I just need you to be able to identify it when the associative property is used. And the associative property is the one that's going to use 3 letters. There's one other one that does, but that one's kind of its own a little bit. And basically what you do is, I'm going to write this up here, 1 plus 3 plus 4 is the same as 1 plus 3 plus 4. Okay, obviously that's true. Those are the exact same thing. But what the associative property says I can do is I can add these ones first, or I can add these ones first, and I get the same answer. And so let's just verify that. 1 plus 3, that's the parentheses indicate I have to do that first. So I would have 4 plus 4 here. And over here, I would have 1 plus, I would have to do the 3 plus 4 first, because that's what's in parentheses. And either way, we get 8. So it is a true statement. And we could verify that really easily, but I need you guys to be able to come up with the justification for that, and the reason is because of the associative property. The next two are often confused with one another, not only because the properties are very similar, but because the words are very similar as well. Identity, inverse, they both start with I, similarly. So this part is a little bit confusing. I want you guys to really be paying attention here. What the identity property of addition states is that if I have a number and I add 0 to it, I get the same number. Obviously, you know that's true. Okay, we could look at multiplication. The identity of multiplication is multiplying by 1. I could take the number 4 and multiply it by 1, and I still get 4. That seems, not significant, right? That seems boring. You know that that's true. And I know you know it's true, but what I need you to be able to do is identify that it is the identity property on a quiz. If you see something like this, this is called the identity property. And so how are you going to do that? Well, what it means, what the identity property means, is you can take a number and have it keep its identity on the other side, right? 4, adding 0 to 4 is still 4. Multiplying 4 by 1 is still 4. The number 4 kept its identity on the other side. The number 4 kept its identity on the other side. That is called the identity property. The inverse property, like I said, is very similar, except we don't want it to keep its identity. We want to go to the identity. So we can take a number like 4 and we can undo it, which will get us back to its identity, 0. There is a number that we can add 4 with. You guys should know it's -4. That you can get to 0. 4 plus -4 is 0. We took a number and we undid it. This is its inverse. We undid the number, and what we did when we undid it is we got to the identity, 0. We can do this with multiplication as well. We can take the number 4 and we can undo it. What do we want to get to when we undo it? Whatever its identity was, which is the number 1. We can take 4, multiply it by its reciprocal, and get back to 1. 4 times 1/4 is the number 1. Remember, identity, we want to take a number and have it be the same on the other side of the equal sign. We want it to keep its identity. With the inverse property, we want to take a number and then we want to undo it. And what happens when we undo the number is we get to its identity. The last property that we're going to talk about is the distributive property. And you guys know the distributive property the best out of all of them. This one's kind of weird because these ones are all addition. These ones are all using multiplication. But the distributive property uses both in the one situation. And like I said, you guys have seen this a ton of times. You have a number out in front of parentheses. You can take that number and you can distribute it by multiplying it to both of the things in the parentheses. So an example of this would be like 2 times 3 plus 5 is the same as, you guys should know this, 2 times 3 plus 2 times 5. Basically, you're taking number 2 and you're distributing it, you're applying it to both of the numbers in the parentheses using multiplication. You might also see it look like 6 plus 10. You should know that 2 times the quantity of 3 plus 5 is the same as 6 plus 10. And this is called the distributive property. So that is all I have for you guys for sections 1.1 and 1.2. Check Schoology for what you should do next.